Buying a new car is a great thrill, but it is also a very big decision. It is very expensive to buy a car these days, so you absolutely have to be sure that you get value for your money. So if your older brother or sister has just landed their first job and they decide to buy a new car, do you think that what you have learned about force and the effect of force in this series could help you to assist them in making the right choice? Hello, and welcome to the last episode of Investigating Forces. Today we will discuss some of the features in modern cars that make them safe for us to travel in. By the end of this lesson, you should be able to compare safety features of different modern cars, evaluate these features by applying your knowledge of forces and Newton's 3 laws of motion, and give scientific reasons why you would recommend a particular car. The most important safety feature in any car is a skillful and responsible driver. So before your brother or sister even thinks about buying a car, they should first ensure that they have a valid driver's license. A good place to start your research would be to page through the motoring section of the daily newspapers and car magazines. What you are looking for is test drive reports. We will look at some of the features of small 1.4-litre cars priced below 140,000 Rand. There are quite a few models in this price range. So, would a 2-door, 3-door, 4-door, or even 5-door suit you best? Is it safe for cars not to have back doors for its passengers? Well, it really depends on why you need the car. If you transport very young children, it could be better to buy a 2-door car, as your little children won't be able to open the doors while you drive. But if your car is involved in an accident, it's easier to help passengers out of a 4-door vehicle, and most modern cars have a safety catch on the door locks that prevents the passengers from opening the doors from the inside. These child locks are standard in most new cars these days. Then, there's the issue of boot space. Buying a sedan ensures that you have a boot in which to put the luggage. But the rear door of a hatchback allows these cars to be used as multi-purpose vehicles. The back seats fold down, giving ample space for you to move small pieces of furniture. Just remember that it's not safe to transport passengers with the back seats folded down. It is illegal in South Africa to transport passengers, even passengers in the back of the car, if they don't wear their seat belts. You should know by now that this is a sensible law. If the passenger doesn't wear a seat belt, he continues to move forward when the car is brought to a sudden stop. He only stops moving when he hits the windscreen or the seat in front of him, and a collision of the passenger and windscreen is very likely to cause serious or fatal head injuries. Can you remember what the scientific explanation is for the motion of a passenger that does not wear a seatbelt? Newton's first law of motion states that a body will stay at rest or will continue to move at constant velocity in a straight line unless a resultant force acts on it. It is the property of inertia of the passenger's body that maintains his motion at a constant velocity. It is little wonder then that the seatbelts in modern cars are called inertial seatbelts. Let's take a closer look at how these seatbelts work. When the car stops suddenly, the passenger continues to move forward with the same initial velocity. The passenger's chest exerts a sudden sharp jolt on the seatbelt, which responds by locking the belt tightly so that it holds him securely in his seat. This ensures that the passenger slows down at the same rate as the car does. Small children should be transported in a child seat, which is strapped into the car using one of the seat belts. It is when you need to apply brakes suddenly and sharply that people really appreciate the action of their seat belt. Let's find out more about modern braking systems. Brakes apply force to the metal rims of the wheel, which we call discs, and not to the rubber of the tires. The brake pads clamp onto the disc and stop the wheels from turning. Why do you think that it is more effective to apply a braking force to the steel wheel rim and not to the rubber tires? The purpose of brakes is to change the kinetic or movement energy of the wheel into something else during braking. When the wheel stops, it has no kinetic energy. Its energy has moved somewhere else. The particles inside the metal rim and on the brake pads, as well as those molecules in the surrounding air, have received energy, making them move faster. This causes their temperatures to increase. Rubber melts and softens at high temperature. If the rubber of this tire were to suddenly gain all this internal energy, it would perish fairly quickly. That's why it's always better to apply the braking force to the metal rim. But applying brakes sharply can cause the wheels to lock. This can be dangerous when a car has to stop suddenly on wet and muddy roads because you'll most likely lose control over your car. This happens because a car is only able to move if there is a frictional force acting between its wheels and the road surface. So, for you to be able to steer the car, its wheels must move on the road surface. When the wheels are stationary, you cannot change the car's direction of motion. It will slip or slide out of control. The same principle applies as we saw in an earlier example on frictional force. Remember, it is nearly impossible to walk on ice because there is no friction between your foot and the ice, and so you can't control your motion. You can't steer yourself. Cadence braking can help prevent a car from sliding. Cadence braking is a method of braking where the driver applies brakes in short, sharp bursts, and in doing so, keeps full control over the steering system of the car. Advanced driving courses teach drivers to use this procedure when coming to an emergency stop in slippery conditions. Luckily for us, motor manufacturers have designed an automatic braking system which applies brakes in the same way as the cadence braking method. When you step hard on the brake pedal in an emergency, this braking system automatically applies force and releases it up to 20 times a second while allowing you to maintain full control of the steering system. This type of braking system is called ABS, anti-lock braking system. Cars with ABS are usually a little more expensive than those without, but they are often rated amongst the safest cars to drive. Since a safe journey largely depends on the driver, his or her comfort, as well as an unrestricted field of vision, are high priority needs when buying a car. Keeping that in mind, here are a few things to look out for when viewing a new car. Can you adjust the driver's seat to suit the size of the driver? Can he or she see over the steering wheel? How easily can the driver adjust the mirror system to suit her needs? Can you watch the children in the back seat of the car without having to turn around? Power steering is also a very nice to have feature to look for in a new car. Power steering allows us to turn the car without exerting much force on the steering wheel. It's much easier to park a car which has power steering than one of the older types of cars, but there's also a danger of oversteering a new car, so it is important to get to know how your car responds before you drive it too fast or too far. A more essential question you have to ask yourself about the car that you're considering is, has it been designed to protect its occupants in the case of an accident? Two of the most important safety features that work to your advantage in an accident are airbags and crumple zones. Let's investigate these a little more closely. How do airbags actually help passengers in an accident? What principles of physics apply to them? Airbags release high pressurized air into a bag when struck suddenly at great force. They form a cushion between the driver and the steering wheel or the side of the car. The cushion allows the driver to come to a stop over a longer period of time. It allows his momentum to return to zero in a little more time than it would do if the driver struck the steering wheel immediately. You should be able to recall that the resultant force is proportional to the rate of change of momentum. This is what Newton's second law of motion tells us. So, Because of the airbags, the resultant force on the passenger is reduced, so he is less likely to suffer fatal injuries if the airbag deploys successfully. Some smaller cars have airbags fitted as standard safety features. Once again, these cars will cost you a little more, but that cost may save a life. Next, we'll look at crumple zones. In the past, most of a car's body was made of metal. Cars had greater mass, and they consumed more fuel per kilometer than the modern cars do these days. With an ever-increasing world population and decreasing energy resources, fuel efficiency is prime consideration for car manufacturers. With advances in the manufacturing of hard plastic, today's cars are made from both metal and quite a considerable amount of hard-wearing plastic, which is lighter and thus makes the car more fuel efficient. The bumpers are usually made from molded plastic, and so too are parts of the front and rear of cars. They are designed to collapse slowly and steadily in a collision. These are the crumple zones of the modern cars. Crumple zones reduce the impact in a collision in a very similar way to the way in which airbags work to reduce force. The crumple zone collapses over a longer length of time than metal parts would collapse. This means that the rate of change of momentum is reduced, so the resultant force acting on the car in a collision and on its passengers is reduced. With less mass to carry, the modern car's fuel performance and acceleration are much better than is found in older cars. In addition, advances in chemistry have led to the development of unleaded fuels. The use of unleaded fuels helps prevent environmental pollution. I'm sure you'll agree with me that most of us can only afford this type of car in our dreams, which may not be such a bad thing, since there is always the temptation to drive too fast in a high-performance car. If you want to talk about real speed, then let's go to a racetrack. These cars are equipped with jet engines. Jet engines work by pushing hot gas out of an exhaust nozzle. The escaping gas therefore exerts an equal force in the opposite direction on the jet engine, and this force propels the vehicle forwards. Do you remember which of Newton's laws makes a similar statement? Newton's third law states that if a body A exerts a force on body B, then body B exerts a force equal in magnitude and in the opposite direction on body A. Rockets work on the same principle. This plastic bottle is pressurized with air, which pushes the water out of its nozzle, lifting it up as the water force out below it. These jet-powered cars are streamlined so they can reach very high speeds. They are designed to minimize air friction. Now, back in the real world, it's time for the task in this lesson. Based on what you've seen in this lesson and your own research, decide which car you would choose to buy in the compact sedan range. Write a motivation for your decision. As part of your research, you may want to find out what tests a car must pass in order to qualify for a 5-star safety rating. Decide whether this rating would influence your decision. Physics affects every action in our lives, and as you can see, smart people make physics work for them. I trust you enjoyed this series. See you soon.